Dear students, today we will learn about the work energy principle. It states that when a force moves a body, it does work and causes a change in kinetic energy of the body. So we can say that change in kinetic energy is work done. And as we know that change in kinetic energy is half mv square minus half mu square, where u is the initial speed and v is the final speed, is equal to work done. What is work done? F force multiplied with distance traveled, to Fd. So here we can now safely say that increase in kinetic energy is total work done by all forces acting on the object. Remember, here contact is not rough. So this work energy principle is very important when the path is not a straight line. If the path of the object is not a straight line, then we will definitely use work energy principle. Also, increase in mechanical energy is equal to total work done by all the forces that act to speed it up minus total work done by the forces that act to slow down the body. That is, when there is a friction, then the contact is not smooth. Here remember, the weight of the object is excluded. So what is increase in mechanical energy? It is the sum of change in kinetic energy and potential energy. So now, what is conservation of mechanical energy? This law is very important. It says that the total energy of a system remains constant provided that no external work is done and no mechanical energy is converted into an other form of energy. So we can say if the object is moving on a plane at certain slope, so mechanical energy at B will be equal to mechanical energy at A if there is no external force, or we can say that if the contact is not rough. So initial mechanical energy is equal to final mechanical energy. This is the law of conservation of energy. Now further details, this what I am doing in this lesson, these you will apply to solve different questions in your this work and energy problems. This page will help you to solve the question. Definitely I will solve the questions in my next lesson. So loss in potential energy is gain in kinetic energy and vice versa. At maximum height, kinetic energy is equal to potential energy. Work done by a net force is equal to change in mechanical energy. Work done by driving force minus work done by the force of resistance is equal to change in mechanical energy. That is mechanical energy at top, you can say here at B, minus mechanical energy at bottom, that is at A. If there is no external force acting, then initial mechanical energy is equal to final mechanical energy, as I told in the beginning. This is the law of conservation of energy. Now, if the plane is smooth, the whole potential energy at B will convert into kinetic energy at A. We say that mechanical energy is equal to mechanical energy at B. If the contact is rough, this is very important now. If the contact is rough, potential energy at B will divide into two parts. One is kinetic energy and second will be work done against friction. So we can say now the potential energy at B or mechanical energy at B is equal to mechanical energy at A plus work done against friction, or potential energy at B will be kinetic energy at A plus work done against friction. So it is better to use mechanical energy at B is equal to mechanical energy at A plus work done against friction. So boys and girls, my all students, this page will help you to understand the how we will use these formula in solving the questions of work and energy. Sometimes the students feel very difficult to solve these problems. So this page is for those students. Just try to understand this page and do it again and again, and then finally I hope you will understand. So this was our today lesson. In next lesson we will discuss something about power, and after finishing power I will solve some question from past paper on this topic. Thank you. Take care of yourself.